Good evening friends, my dear friends and my dear students, welcome back. So we are going to talk about the compounds of group 16. Okay, I hope anybody is there. Okay, I am not able to see you people, at least ping me, let me see anybody is there over there. Okay, we will be talking about group 16. Okay, okay. Yes, just to recap what we have done today before 45 minutes, okay. We discussed about the group 16 elements, the periodic trends, then chemical properties, then we discussed about the abnormal behavior or anomalous property of oxygen, then we discussed about the hydrates and halides of group 16. I think people are not pinging me, okay, just to have a recall, okay, just we discussed half an hour back about general characteristics of group 16, periodic trends in properties of group 16, chemical properties as well as abnormal behavior, okay. So now we will be talking about the individual compounds of group 16, that is oxygen compounds, oxy compounds, okay, as well as what we call as sulphur and its compounds, okay. Uh, just oxygen, oxides of oxygen. So hello Radhika, fine, are you able to listen? Okay, so just I am giving oxygen now to all of you, okay, more important element for living system. If there is no oxygen in the earth, no living system exists, okay. Just we will discuss about the oxygen and its compound and as well as the allotropic form of oxygen like ozone. Then we discuss about the sulphur, allotropic modifications of sulphur and compounds of the sulphur, okay. So now when we talk about anomalous property, as already discussed, because of a small size, oxygen is the most, okay, the second most electron negative atom or an element in that group when compared to your halogen, that is fluorine. Fluorine comes in the 17th group, okay, and the small size of the oxygen atom, okay, which is capable of forming p pi bonding. Because of this, what it makes is a special property for multiple linkages, but a non-availability of D makes not to go for multiple characteristic. That is the reason it exists as diatomic as well as gaseous state, and it exhibits the low boiling as well as the melting point and low density, okay, because of it is not going to form multiple bonds. Then when we think of what we call as the oxygen to oxygen, bond distance is about roughly 1.21, okay. So that is what when we think of the distance between oxygen to oxygen atom. So this is where the thing goes as 1.1, oxygen to oxygen, oxygen to oxygen, it goes with respect to 1.21, okay. The distance between yes, so now you can think of the oxygen to oxygen is 1.21 angstrom, okay. When we think of this, which is a very small distance when compared to, okay, the single bond length and the I bond energy, because of small size the bond energy goes as 118 what we called as kilocalories per mole, okay. This is the energy which goes, and most of energy is required to break the bond. So thereby the oxygen becomes what we called as the strong. When it comes to fluorine and fluorine bond energy, so this is about just 38 kilocalories per mole, and hence when compared to oxygen, fluorine is very reactive because the bond dissociation energy is very less. Oxide ion is not easily polarized, that is one of the important property. So it is called as odd ion because it cannot be polarized easily. So this is also one of the very important property of oxygen because of anomalous property. And non-availability of d orbitals in the valence, since oxygen has no d orbitals, okay, its valence is only what we call as 2 covalency, while other elements having empty d orbital exhibits the maximum covalency of 6. Okay, so this is all about what we think of the oxygen anomalous properties. Now we think of how oxygen is prepared and what all its properties. Oxygen found in the free state as the molecular oxygen as O2 gas, which exists in the free state. About, as I already said in the beginning of today's class, that is 21% by volume in the atmosphere. Okay, so the next which we think of in animal tissues, this exists as 50 to 70%. 50 to 70% exist in animal tissues. Okay, and about 50% in the earth crust. It exists about 60-50% in the earth crust. The preparation, when we think of the preparation of this oxygen, it goes by like this: by eating oxides of metals like noble metals or heavy metals. So when Hg, okay, that is oxide, when heated, which undergoes decomposition to form what we called as Hg plus O2. So now when we want to balance, this will be 2HgO with respect to 2Hg, and oxygen is going to form. Similarly, when silver oxide upon heating, that's what, 2 molecules of silver oxide upon heating, it will form 2Ag plus the molecular oxygen. So similarly, when barium oxide decomposes, that is 2 molecules of barium oxide to give BaO plus O2. So not only this, by eating what we call as several peroxides and their salt will also give oxygen. So like hydrogen peroxide if I take, so when we heat it in presence of a catalyst called as manganic oxide, so that will form the water plus molecular oxygen. This will be obtained. So apart from this, we can prepare this by using commercial method by electrolyzing what we called as electrolysis of sulfuric acid, okay, which gives us the molecular oxygen. When H2SO4, okay, is electrolyzed, which give 2H plus SO4 2 minus, the sulfate ion. At cathode, okay, we all of you know that reduction takes place, so that will give 2H plus 2 electrons will give us 2H, which in turn finally gives respect to hydrogen gas. Whereas at anode, so this is the reaction which takes place as H2O plus ion gives rise to, combines with this, so this forms 6CO2 plus 6H2O. So now you can see it can form n number of compounds with respect to what is called as metals, non-metals, as well as the compounds and organic compounds. Not only the simple compounds, or which is also with organic compounds. Next, coming to structure of your oxygen. So when we think of the structure of oxygen, okay, so now when we think for the reactions with metal, okay, so that is where I will be talking about. So just look at the reaction, because when you think of reaction of oxygen, it goes with the sodium. The first example, if I take active metal, when it interacts, so this forms the sodium oxide, okay. So that means if you want to look here, the balancing of done will be done with respect to the 4 sodium. So when it reacts with the calcium, then it forms the calcium oxide, okay. Or if I take another metals like aluminum, when it reacts with the oxygen, the 3 molecules, it is going to form a special component called, as you all of you know, that Al2O3, which is the bauxite, which is the ore of aluminum. Okay. So next, when you think of what we called as reaction with respect to non-metals, I think all of you know that non-metals means some of the second and third period of your p block elements, like what we called as sulphur, which goes with oxygen to form sulfur dioxide, or when it reacts with the carbon to form carbon dioxide, or when it reacts with the hydrogen, okay, in presence of a catalyst like platinum, okay, this is going to form the water molecule, or when the phosphorus is made to react with oxygen, 5 molecules of molecular oxygen, which forms the P4O10, okay, phosphorus pentoxide, it is formed. So then when we look for other reactions such as the compounds of the other elements, that is where when it reacts with SO2 plus O2 in presence of the platinum, so that will give us the sulfur trioxide. So this is the process which is used in contact process of manufacturing of the sulfuric acid. So this is the raw material for the sulfuric acid preparation. So when we think of another reactions like ammonia, when is made to react with the oxygen, so which gives as the 4 molecules of nitric oxide plus the 6 molecule of water. So this once again a very important reaction where we can get NO, that NO can be finally used in the manufacturing of nitric acid by Oswald process. So thereby NO is a good raw material which can be obtained by the oxidation of ammonia. Next, when we thought of the reaction with the mineral acid like HCl, when it is reacts with the oxygen molecule in presence of cupric chloride, that is CuCl2, okay, it is going to form a very important component, the molecular chlorine, to get the H2O. So this process is called as Dacon's process, where the chlorine, the pure chlorine molecule can be obtained. So these are the important reactions with respect to oxygen, because one is acts as a raw material for your sulfuric acid contact process, and another one acts as Oswald process, and another one gives for Dacon's process. Okay, when it comes to organic compound reactions, so you all of you know that it undergoes oxidation, or what we call as the combustion process, or what that is where when methane is made to react with the molecular oxygen, okay, it is going to form the carbon dioxide plus the water molecule. So when we think of an alcohol, the methanol on oxidation in presence of the platinum wire or a gas to form a formaldehyde HCHO. So that means any alcohol on oxidation gives with respect to the aldehydes, along with the water molecules formation takes place. Next, the important reaction which in biochemistry which we talk about is the oxidation of glucose, C6H12O6. So why we breathe? That is because to not to survive, it is to break down the glucose molecule, which gives an energy source. That is where the 6CO2 plus water plus what we talk about called as Q quantity of energy. Okay, welcome Kumar Adya. I think I am able to look your responses. Okay, Apeksha, welcome back. Okay, so now we are talking about the oxides of oxygen. Okay, I think you are able to look into the things. If you have a doubts, please ping me, let me know if you have any doubts. Okay, the next, when we think of the structure of this oxygen, it is having a special structure. So that's where I am going to write the structure over here, that is the Lewis dot structure. I think you all of you know this. So oxygen atom, okay, one more oxygen atom, you can see here the 2 unpaired electrons, whereas another 2 involves in the bonding with another atom. So here you can see here the lone pair where you can find the bond between them. Okay, so that is where this is a one way of representation, or we can represent in this way also, where we give the dots form in this way. So where you can find 2 here, as well as 1 singlet unpaired electron here, 1 singlet unpaired, and 2 unpaired electrons over here. So this is also give the structure of your oxygen, electronic structure of oxygen, where you can find unpaired electron. Apart from this, we can give the structure of oxygen as molecular oxygen as like this. So where you can see oxygen, where you can find the lone pair of electron over here and the 3 electrons over here. So this is gives. Okay, I think now you got the things. That is the structure which I given right now is the 3 electron bonds have the unpaired electrons each. The 3 electron bond as one of the strength of the single bond. Okay, so this is a special structure when we think of this. So now coming to uses of oxygen, oxyhydrogen and oxyacetylene flames, in order to get them, so for cutting and welding purpose, this oxygen plays a very important role. The liquid oxygen is mixed with what we called as the finely divided carbon is used to substitute for dynamite in coal mining. When we want to blast the coal reservoir, so there we use the oxygen mixed with finely divided carbon. Next, the important use of the oxygen is the liquid oxygen is an important constituent of fuels in the rocket. Yes, definitely. Kumar Aditya is asking about the video will be sufficient for NEET. Yes, definitely. What are the points which we are going to cover and the CPP which you are going to give for you people, if you follow that, I think that is a more than sufficient. You have to just understand the concept what we are going to explain, and you have to take our CPP, which is the most important questions which we are giving to you people. If you answer and if you get back to us with the doubts, so we can give the clarification. That will help you out for getting into the NEET examination. That means you can clear the examination. So next is oxygen is used as an oxidizing agent in several preparations. So that's what I give so much of reactions which you can think of. Next, coming to important things of this oxygen is the oxides of oxygen. So that's what when we think of the classification on the basis of oxygen content. So that's where we have what we call as normal oxides, we have polyoxides, we have suboxides, and we have mixed oxides. When it comes to the polyoxides, where you can find Hg2O, mercuric oxide, is what we call as the normal oxide. Okay, when we think of H2O, then we think of MgO. These are all called as normal oxides. Okay, so when we think of the other oxides, that is where we think of polyoxides of oxygen. So where you can expect barium oxide as well as sodium oxide. Okay, then you can find with KO2 or rubidium oxides. Okay, and in the form of dioxides, that is where we talk about these are all superoxides especially. And when we think of dioxides, where you can find a manganic oxide and lead oxide, PbO2. Okay, then come to suboxides. So here you can find the suboxides. These oxides contain less oxygen than the expected from what we call as the normal valency of its metal. So for example, if you take an example of nitrous acid N2O and carbon suboxide which is called as C3O2, when you get these kind of things, these are called as suboxide because the oxygen content is less when compared to its respective metal or the element which is bonding reaction. Next, the fourth one is called as the mixed compound oxides. There you can find the n number of oxides like what we called as the ferric oxide. Okay, so which is nothing but Fe3O4, where it is a combination of FeO plus Fe2O3. Similarly, another oxide which we can think of Pb3 and O4, which is the combination of 2 lead oxide plus PbO2. Okay, these are called as what we call as suboxides. Next, the classification based on their chemical basis or chemical reactions. So that is what we call as acidic oxides, that is called as acid anhydrates, which we talk about. Like example, when we think of carbon dioxide combined with water to form H2CO3. Okay, the majority of what we called as the non-metal oxides okay, like carbon dioxide, sulfur dioxide, okay, or phosphorus, nitrous, okay, these oxides have high oxidation states. So that is what we can think of chromic oxide, vanadium oxide, manganic oxide. So these finds lot of application in the battery technology of oxides is concerned. So next is we think of basic oxides of this. So what are the basic oxides which we can obtain from oxygen? So that's what the basic oxide like Na2O, sodium peroxide, when it made to react with water, it forms sodium hydroxide. Then alkali is going to be formed. Similarly, when the calcium oxide is made to react with the mineral acid of HCl, so this is going to form what we call in component calcium chloride plus the water. Okay, next we can think of some amphoteric oxides, that is zinc oxide is made to react with the sodium hydroxide alkali, so that is going to form sodium zincate, okay, Na2ZnO2. These are the standard reactions, okay. Then zinc oxide is made to react with HCl, so you can get zinc chloride. Okay, these are all very important components which finds lot of application when we think of their chemical properties is concerned. Next important component of oxygen is, which we talk about, is the what we call as ozone. Okay, when we think of ozone, you all of you know that it's a very important component in the outer atmosphere, that is called a stratosphere, where the 3 oxygen molecular, that is dimolecular oxygen, when it interacts to form 2 molecules of O3. So when you look at the energy, where delta H is think of what we call as plus 68 kilocalories. Okay, so now when we think of this is an endothermic process, remember here, so what is happening here? So energy is absorbed, so thereby it is going to form a molecular component. Since the formation of ozone is an endothermic reaction, okay, it must be carried out at very high temperature, hence it is prepared by the silent electrical discharge, which makes what we call as the ozone can be prepared. Next, the ozonoid oxygen, the mixture, okay, which is 5 to 10% ozone by volume, is called as ozonoid oxygen. But ozone is very dangerous, we cannot take this because it is fatal to life. Because what is the reason for this? It decomposes. Once the ozone decomposes, it forms the 2 O3 gives rise to 3O2. In that O3 will give us oxygen plus 1 nascent oxygen. This nascent oxygen is highly reactive, that will bring about lot of reactions in the biological system to form majority of the component like this. So that is what, why it is called as a fatal reaction is this: O3 plus H2O plus 2 electrons will give us the 2 hydroxyl ion. So once this happens in acidic medium or in basic medium, so that creates a lot of problem for biological system. That is what we call as the free radical mechanisms are sets in. So that is once again a very dangerous condition. Now coming to the uses of this ozone, it is mainly used in sterilizing agent for what we call as improving the atmospheric crowded places like cinema halls, underground tunnels. So there it finds, that means purification of air can be done. Since ozone decomposes readily to give a nascent oxygen, it is used as a mild bleaching agent for bleaching oil, or what we call as ivory, or what we call as the wax and delicate fabrics, that is called as the dry cleaning which you think of. So that is where they leave ozone gases in between the hanged class, so without affecting your fabric, so that will make a very clarity in the removing the odor of that materials. Next is the old paints, if you want to remove, we cannot put chlorine because chlorine goes for permanent bleach which will decolorize the color. Hence in those conditions we can use this ozone as the decolorizing compound. It is used in manufacturing permanganate, okay, potassium permanganate especially, and artificial silk, that is what, and artificial what we call as the synthetic camphors. So these are all the applications which we can find, and it is also used in detecting the position of the double bonds in unsaturated compounds, because whenever we talk about organic reaction, So where unsaturation has to be found, there we think of a molecule like ethylene. When it is made to react with oxygen, it is going to form a special component called as ethylene ozonide, which on hydrolysis will give you the two molecules of formaldehyde. That is what, let me write the structure for that. So that will go like this. So where you have CH2 here or CH2, once again this oxygen gets over here, and whenever this breaks you are going to get CH2O plus CH2O, that is nothing but HCHO with the elimination of water. So that is hydrogen peroxide, sorry. So that will give us idea about this molecule. Coming to the structure of your ozone, the structure of ozone goes like this. It is a resonance hybrid. Okay, once again if you look at the structure, it will have the oxygen atom, and you can find an oxygen atom over here, the lone pair of electrons here. So then it will get the excess charge over here, lone pair, and it gets the positive, and you can find the lone pair electrons over here. The resonance hybrid of this will go like this. So this will get into this, only the shifting of double bond with respect to this atoms takes place, and you can find the electrons over here, so which will have negative charge. Similarly, when you find here 6 plus 2 here, you can find a negative charge. So this is the structure. The OO bond distance over here gives as 1.28 angstrom. Okay. So now we'll be looking for the test, the strongest, the test which we want to find out with the ozone is the smell. The first thing is it turns the alcoholic solution into benzidine brown. So that is where we can use this, and in order to identify the metallic mercury, when we treat the mercury with respect to this ozone, it immediately, okay, tailing of mercury, this is called as artificial comet, which sometimes the people talks about. Then when we treat the ozone with iodide paper, that will turns into blues, that is starch paper. So that is the best way of identifying ozone. So then it turns an alcoholic solution extremely, that is tetramethyl base to violet in color. So these are the special properties when it comes with respect to this. So now when we think of what we called as oxygen compounds and oxides of this, so now we will be talking about the previous contest question today, which I discussed in the earlier session. So that is what the oxygen is denser than air, so it has to be collected over what, this is what we are thinking of. Yes, that is what Radhika is asking some question. I will come to back to Radhika after this part. So oxygen is denser than air, it is collected over, options were water, spirit, mercury and kerosene. So the answer was A. So that Deepak K Sharma got the right answer. Okay, so congratulations Deepak Sharma. Okay, so now the today's contest question goes like this. When the lead storage battery is discharged, okay, which is the right option for that? That option goes like this: sulfur dioxide is evolved, lead sulfate is consumed, lead is formed, sulfuric acid is consumed. I hope you are done. Yes, I hope you are done with the answer. So now we will continue with this oxygen. I think Radhika is asking some question about ozone, whether it acts as oxidizing agent too. Definitely. Yes, before getting into this, let me talk about Radhika's question. Let me answer for that. So if you take the ozone, as I already said, it decomposes to give the molecular oxygen as well as the nascent oxygen. whenever we treat any of this component, if you want to reduce, that is if you want to bring about oxidation process, take an example of lead sulfide PbS. Okay. So when it is treated, so automatically it combines with the nascent oxygen, this will converts into lead sulfate. So thereby what you can see, the oxidation state has been changed for lead. So that brings about oxidation agent. So that is why definitely this gets into oxidizing. Not only this reaction, you can give n number of reactions similar to this, okay, with respect to hydrogen sulfide, where also H2S when you treat with the nascent oxygen, so then it will give us the sulfur precipitation takes place along with the formation of water plus what we call as O3, sorry, O2 is going to be formed, molecular oxygen. Or if I take potassium iodide, that is aqueous solution, when you treat with called as ozone, so that is called as aqueous solution of potassium iodide. So there also you can find it forms potassium hydroxide along with iodine is liberated. Okay. So this is what the important reactions like what we called as oxidizing agents. I hope you got the things, Radhika. I explained the why it is called as oxidizing agent 2 also. Okay. So now coming to the sulfur, the second element of this group where we talk about. Okay. So already I discussed about majority of this components, how they exist. That is sulfur exists in the form of PbS, that is called as galena, or in the form of zinc blend, that is called as ZNS, iron pyrites, okay, and Epsom salt in the formation of magnesium sulfate in the combined state. So the extraction and all we have discussed a lot. Okay, now coming to what we called as the allotropic forms, which already I said what we called as rhombic form, monoclinic form, as well as the plastic form of sulfur. So where this is, that what I said, on cooling it forms what we call as shrinkage, that it is what we call as the brilliant powder of sulfur with the sticky nature. So this forms, so that is what we called as the plastic sulfur. So when it is treated with by adding milk of lime with the sulfur, so that finally decomposes to form HCl. So that is called as milk of sulfur. This is also one form of sulfur where you can extract, that is allotropic forms. So when it comes to the properties of this sulfur, ordinary sulfur is a pale yellow, okay, what we call as brittle and crystalline solid, insoluble in completely in water, but highly soluble in carbon disulfide as well as the non-polar solvents like benzene and what we call as the turpentine. Okay. So it is marked as what we call as tasteless as well as the faint in odor. That means the especially chemical should not be smelled, we could not check the odor, but faint odor which we think, but whenever we feel the odor of this compound, it is always like a pungent smell. So that is what you think of the rotten egg smell whenever the hydrogen sulfide, the sulfur, okay, that is what we call as the yellow part. When we boil the egg, we can find certain sound or what is called as a smell. So that is where the sulfur smell goes. So this sulfur on burning in air, it forms sulfur dioxide. So this is what gives the SO2. So this sulfur dioxide on treating further with oxygen, which gets converted into sulfur trioxide, so which is the one of the important component for the contact process for the manufacturing of your sulfuric acid by contact process. So next, when the combustion if it takes place with respect to other elements like what we call as carbon, hydrogen, chlorine, iron, okay, it forms the respective sulfides. If it combines with carbon with sulfur, which gives us the carbon sulfide, carbon disulfide, or it combines with hydrogen to form hydrogen sulfide, and if it can give another important compound is called as sulfur chloride, that is S with Cl2. So this is a special component, this is highly unstable, thereby this goes for dimerization to form S2Cl2. So this sulfurous chloride, this is one of the very important chloride which is used for chlorinating as well as sulfurating agent which we use in organic chemistry. So when we think of reaction with respect to alkalis, definitely this sulfur reacts with alkalis to form the following compounds. So that's why when the sulfur is made to react with one of the best known soda alkali, that is sodium hydroxide, So that gives us 2Na2S, okay, plus important compound Na2S2O3, okay. So this is a very important component. Then if it is made to react with the Na2S with further sulfur which is in excess, I call it as, so that will form a special component called as Na2S5, sodium pentasulfide. So this compound finds lot of application, okay. So now coming to uses of sulfur, it is used in the manufacturing of sulfur dioxide, sulfuric acid, carbon disulfide, and especially in the form of gunpowder, okay. So that is where, so the charcoal, potassium nitrate and the sulfur, if they mix, they will get a special powder which is called as the gunpowder, which is used for explosive in coal mines, okay, or underground tunneling, obtaining these powders are being used to blast the rocks, okay. Next, in the match industries, especially in the fireworks, okay, that is where the cracking of fires is very dangerous, because that will give sulfur dioxide and sulfur trioxide, which later converts into what we call as acid rain if the moisture is more in the atmosphere. So that is the reason. One is, next is disinfectants, it is used, and the sulfur finds maximum in medicine because of its what we called as special properties to dewact oxygen from the surface of the cell. So that makes the lack of oxygen for the viruses, and the viruses will die or bacteria will die because of lack of oxygen. So that the oxygen will be consumed, completely consumed by your sulfur. So that is why it has a good medicinal value also. In the manufacturing of sulfur dyes, majority of the colors which you obtain, so today they are all basically because of this dyes. So there we can make use of this, and apart from that, you all of you know that the tires which we use, okay, the natural rubber cannot be hard or soft, it will vary with the temperature. If you want to get a desired property for that rubber, we do a process called as vulcanization. So there also the disulfide linkage occurs because of this sulfur. Hence sulfur is having lot applications. Coming to the compounds of sulfur, when we think of compounds, it can form n number of compounds, especially the hydrogen sulfide, okay, that is one of the best component which you are used majority of this hydrogen sulfide in the case of your salt analysis. That is what, if you want to remove the first group of element after the treatment with HCl, you are going to make use of the passing of H2S gas. So there the zinc sulfide or lead sulfide can be completely eliminated for your rest of the salt analysis. So these are the one of the important property. Apart from this, hydrogen sulfide acts as a reducing agent and as well as what we call as a good acid also, that is aqueous, because of dissociation takes place, the protons are given into the solution. That is what, when you pass H2S into water, that is what I call as an aqueous solution of H. So that will give us H plus HS minus. This is once again HS minus, which we call as a thiol group, which is plays an important role in bringing about what we call as cascades of reaction in biological system. That is what the thiol system, mercaptans, which we call it as, and this also finds lot of application in the case of what we think of medicinal values. So next important compound is sulfur dioxide. So the preparation already I have discussed. Coming to the properties of the sulfur dioxide, it is a colorless, okay, poisonous gas and soluble, which is highly soluble in water, and it is creates a pungent smell and as well as the suffocating nature. That is the odor of this oxide of sulfur dioxide is suffocating nature, and it is heavier in air, okay, heavier than air, and it can be liquefied by applying the atmospheric pressure. And the liquid sulfur dioxide is colorless, that is also very important, and it forms a non-aqueous solvent. So that means if you want to bring about certain chemical reaction without using water, so we can make use of this liquid sulfur dioxide, okay. So this is very important. So coming to the next compounds of sulfur which we are talking about is the sulfates, especially the sulfides. So when we think of this sulfates and the sulfides, they have a special properties. If you think of this sulfur dioxide, okay, sulfur dioxide, that is where I am talking about the next component is the SO3, and next we will be talking about SO4, Okay. So coming to SO3 is a good dehydrating agent, okay, and when it made to react with water, so this is going to form what we called as the sulfuric acid H2SO4. Okay. So this is once again it exists in three forms, that is alpha sulfur trioxide, beta sulfur trioxide and gamma sulfur trioxide. So they vary with respect to their boiling points. The alpha sulfur trioxide will have the boiling point as the 17 degrees, it is a melting point. Later I will be talking about boiling points. Then beta SO3 will have 32.5 degrees centigrade, okay, that is also melting point for this. When we think of gamma sulfur trioxide, which will have 62.2 degrees, and here the atmospheric pressure is also very important. Here the atmospheric pressure keeps varying with respect to this, and the decomposition of any of these sulfur trioxide will give us sulfur dioxide as well as the oxygen molecule. Okay, so this is a basic thing, and when we look into the structure of this SO3, this is very important because majority of the oxides of sulfur gets into this structure. That is why, so look at the structure, sulfur goes like this at the center and it forms a dative bond, coordinate covalent bond with oxygen, and it forms the double bonded compound with this. So then it can go for resonance hybrid, okay, that is where it changes its structure like this. Okay. So next the sulfur trioxide, if it goes for polymeric structure or what we call as tetrahedron form, so the structure goes for this as like this, sulfur will be at the center, then it goes for double bond with oxygen, so then the oxygen goes over here, the second valency of oxygen goes with respect to once again the sulfur linkage. So this sulfur linkage goes with oxygen and it goes with sulfur, so thereby you can find this kind of nature. So now you can see how the complex structure this sulfur trioxide, that means you can see here one molecule of this, one molecule and one more, 3 molecules of sulfur trioxide, if they go, they forms a cage or a chain kind of molecules, or if you open this, if you break this, it will form a linear chain also. So that will mimic the structure of your sulfate ions. So now apart from these oxides, it is also forms oxydes of sulfur. Okay. So there are n number of oxyacids, that is where we will be talking about. The first oxide of sulfur goes as the cargose acid, that is what the commercial name cargose acid, which is basically having the molecular formula H2SO5. Okay. So this is also called as peroxide disulfuric acid, okay, that is a molecular formula, and this, and another acid is called as the Marshall acid, MARSHALLS, Marshall acid. So where the molecular formula goes as H2S2O8, and one more important acid we all of you know that is the fumigating sulfuric acid, which is called as oleum, OLEUM, okay, which is nothing but H2S7 H2O7. So this is your oleum. So then you can find this comes under the category of polyacids also. Apart from this, you can find certain acids called as thioacids. So these are found usually when the sulfur containing amino acid undergo hydrolysis or the breakdown in the biological system, you can expect these kind of acids. That is what we call as thiosulfuric acid, H2S2O3. This is called as thiosulfuric acid. Apart from this, this sulfur forms another compounds called as thiosulfates, okay, and sulfurous acids. So these are the other components of the sulfur. So basically when we think of sodium thiosulfate, which is also known as IPO, which is basically used for developing your what we called as photographic films. So where silver halides will be used in the photographic things, when it is exposed to light, so that will undergo decompose, the silver halides will decompose, and thereby we are going to make use of the removal of unwanted things by using sodium thiosulfate. Thereby the majority of the compounds of sodium sulfides as well as what we call as thiosulfides and oxygen compounds plays a lot importance in applications is concerned. Okay. So that is where we will be talking about. Coming to the end of today's session, so we will be talked about the anomalous behavior and oxygen, oxides of oxygen, ozone preparation, their properties, sulfur and its allotropic modifications and compounds of sulfur which we have discussed. Okay. So now, so after this session, I think all of you know that there is a class practice sessions. All the passport users has to log in immediately and answer all the questions which we are given and which were selected on the today's topic. Okay. All the best for joining us.